So in our previous video, we have talked to you about a very special type of function called the even function or the odd function. In this one, I'm going to talk to you about periodic functions. So let's get started. Now, before we move on to see the definition and everything, let's just take two simple examples. So we know that sine 30 is half. What if I ask you what is sine 390? You will say that this is also half because 390 can be written as 360 plus 30. Similarly, consider the fractional part of this function. So if I have the 0.3, the value will be 0.3. If I have the value 1.3, the output will be again 0.3. And for all the possible inputs like minus 0.7 or minus 1.7, you will have the same output. So what do we observe here? Forget about all these values that we have worked out. You consider fx equals to sine x, gx equals to fractional part of x. All of a sudden, you just notice a very similar property. They repeat their values after a certain interval. These kind of functions are called periodic functions. So mathematically speaking, if you are taking any function which is getting repeated after a specific time, it's called the periodic function. This t is called the period of the function. For example, sin x, cos x, sec x, cosec x, all these things are periodic functions with periodicity 2 pi. Tan x, cot x, they are also periodic with periodicity pi. And if you consider the modular sign, all of them will be actually periodic with pi. Now, this is very important. You have to see all the trigonometric functions are periodic. Next, you're going to also learn about inverse trigonometric functions, etc. These kind of concepts will be very, very helpful. Now that we understand the basic definition and some examples, let's talk about some basic properties that it should possess. If you have any function fx which is periodic with the period t, then f of ax plus b will also be periodic and the period of the function will be t by a. You know that cos x is actually a periodic function with periodicity 2 pi. So if I consider cos of 3x plus 5, this will be also periodic. And how will be the periodicity? Obviously, x is associated with 3 here. So if you look at the original one, ax plus b, this will be 2 pi by 3. Now here's one important thing. If you just consider 3x plus 5, this is actually a linear in x. So this is going to be periodic only when you have a linear expression here. For example, if you consider sine 3x plus 5, 2x plus 3, you will see that this is perfectly okay because it's a linear expression in x, and also the original function sine is actually periodic. But if I take sine of root x, so you can clearly see this is not periodic, so simply it's not a periodic function. The next portion is very, very crucial because you need this formula for a lot of sums, especially for MCQs and different types of sums you will have in different competitives as well. Suppose I'm considering few functions, they are actually periodic with respective periodicities. If you consider any linear combination of them, you will see that basically the combined function will be also periodic, and the periodicity will be the LCM of the respective functions if this is not even, and if this is even, so the periodicity will be half the original one. All right, so let's just take some examples so that we have a very clear working idea of this particular property. So first of all, let's consider this. If you consider the each and every portion, you will see that there's sine, cos, tan, so all the trigonometric functions which are periodic. So we have to find out the periodicity of this function. What we do is very simple, try and look at each and every component separately. Start with this one. As you know that this is of the form ax plus b, and this b has no contribution at all. The contribution will be from a. Sine is having the period 2 pi, so this will be 2 pi divided by pi by 2. You remember that was t by a, so this is 4. Look at the next part. This 2 has no contribution. Here we don't have this b going on, so we simply have this ax. So it's going to be 2 pi by pi by 3 because cos originally has the basic periodicity of 2 pi. You have the 6. Finally, no contribution from the negative sign, no contribution from b. Tan is actually having the period pi. Now this is very important. Just because you wrote sine and cos as 2 pi, don't just get confused. So this is 4. Now look at all the individual components here. What you are going to do is take the LCM, because this function is neither even nor odd. So definitely don't have to do half, because if it was originally even, you have to do like half into 12. But in this case, you simply take the LCM and that's it. So at the end of this video, I hope you understand the basic reason of periodic functions, how you can understand this, the definition, some properties and application. In the next video, I'm going to talk to you about another special type of function, so stay tuned.